Okay, back for our second round of crappy Sudoku, aka Gaussian elimination, except this time we're going to attempt to do it using a calculator. So I've downloaded an emulator. I'm hoping that this is going to work. So basically what we've got, this is a question from your textbook on page 124. This is question 9. So the cost of a movie ticket varies according to the classification of whether you're a student, adult, or pensioner, and the table below summarizes the cost for the 3 different families and the total cost as well. So the first thing that I did was I wrote this as an augmented matrix. So again, just using the coefficients there and the total cost as the value column. And then before I chucked it into my calculator, I could see straight away that this row here was all multiples of 2, and so therefore I just simplified it by multiplying by a half. Once I did that, I then swapped it to the first row. And the reason that I did that is because now I have this cascading diagonal of 1s here. So that's good. It makes it a lot easier when I'm dealing with 1s because I can multiply it by whatever I want. All right, so this is where we're going to attempt to now put it into the calculator. So I apologize that this is a bit tiny, but hopefully you can sort of follow along with your graphics calculator. If I change the view window, it might go a little bit funny. Let's try just doing this anyway. Okay, so this is just in the, if you go into your regular calculator menu, this is in the Run Matrix menu. So just a normal working space. And then we're going to go into matrices/vectors, so that's F3. We're going to input a matrix, and for this case, it's going to be a 3x4 matrix, so 3 execute, 4 execute. Let's check that that works. Yes, excellent. All right, so now can I type in my values? 1, yes, good. 1, 1, and 35. And then the next row was 4, 1, 2, and 58. And then the last row was 6, 2, 1, and 82. So let's just go back to that question to check that those values are right. So this would have been 70, 58, and 82. Yep, cool. Okay. And I think the rest of those coefficients I've put in correctly now. All right, so the first thing that I think I'm going to do, why don't we go through a couple of these row operations? So if you go into the row operations, we've got a couple of different options here. So the first option is that we're going to swap any row. So if I wanted to swap row 1 into row 3, that's how I would do it, and then we would hit execute. But I'm going to swap it back now because I do want them in that original location that I had them in. Okay, the other thing that we can do is we can multiply any row by a scalar value. So we can't actually divide by 2 or divide by 3 or anything like that. We would have to do times by a half or times by 1/3, for example. So this k value, that's the number that I would be multiplying it by. And if I wanted to multiply it by 1/3, which is the same as dividing by 3, I would just put it in as a fraction 1/3. And then I would want to do that for row 2, let's say. Now I don't actually want to do that, so let's exit out of that. And then we've got the this third button here. Now this is the one that we're probably going to use the most of, but this button is also kind of the craziest one. So I'm just going to show you this row add function. So effectively what you're doing is you're just saying I'm going to add the row that I have currently selected. So if I go back, you can see I currently have this third row here selected. So I would add that to row 1, and then I could replace it into row 1 or row 3. All right, the last button here is this crazy button here, and this is the one that kind of hurts my brain a little bit. So you have to select the row that you want to multiply. So let's say that we wanted to multiply row 3. So we would have to select row 3, and let's say I want to multiply that by 1, and then I want to add row 1 into row 2 and replace into row 2. So this would be the rows that we're adding. So remember, you've selected a row, so you're adding, say, row 2 into the row that you've selected, and then you're going to replace that into either row 1 or row 2. All right, so a little bit hard to sort of explain that on the calculator. I hope we've got the idea. So let's go back, let's go back into that menu there, and let's have a go at some of these row operations. So the first thing that I can see that I want to do is I'm looking at this row 1 and I've got 1 in the first little slot here. So what I'm going to do is I'm going to multiply 1 by -4 and then I'm going to add that into row 2. So let's try that. So we're going to multiply that row by -4 and we're going to add that to row 2 and I'm going to replace in row 2. All right, let's see if that works. Oh, damn. I don't think that worked. I think I had the wrong row selected. Can we go back? I don't think so. I don't know if we're going to be able to do this. I'm going to start again. One sec. All right, let's try this again. So if we go row operations, I want to multiply a row. So let's try multiplying by -4 for row 1. And I want to add that into row 2. So let's see if that one works. Ahaha, excellent. So now you can see that we've got a 0 in this first column. So that's good. Now I want to try and do the same thing here for row 3. So I want to multiply row 1 by -6 and then add that into row 3. So let's try that. So we want to multiply it by I'm just going to double check that. Let's double check. Yes, so we want to multiply it by -6. So times by -6 for row 1, and I want to replace that into row 3. Excellent. Yes, now we're getting it. All right, so let's move along and let's have a look at trying to clear out some of these columns. So what I could do for this second row is I could multiply everything by -1/3, and that's going to give me that 1 there in the diagonal. So let's try that. So I'm going to multiply -1/3, and I want to do that for row 2, and let's execute that. Okay, so now we've got a 1 and a 1. That's good. So now what I can do is I can use this one here to manipulate this equation. So if I multiply this by 2 and then add it into row 3. So let's try doing that. So I'm going to multiply, whoops, what was it by? Multiply by 4 and add into row 3. So I'm going to multiply by 4 for row 2 and I'm going to add that into row 3. So let's see if that works. Excellent. All right, so the last thing that we need to do is we need to divide this through by -2.333. So we're going to have to do this as a fraction. So -2.333 as a fraction would be -7/3. So I'm going to divide by -7/3. So dividing by a fraction is the same as multiplying by the reciprocal. So I'm going to multiply by -3/7 and then replace that into row 3. So let's try doing that now. So we're going to multiply by -3/7 and we want to do that for row 3. All right, let's execute that now. Did that work? So we've got our lower triangle here of zeros and we've got our cascading ones here. Now I could keep going and I could keep manipulating each of these equations until I got the completely reduced form, but I think that's going to be a little bit tricky. So what I'm actually going to do is I'm going to move this over to the OneNote and I'm going to finish showing you with backtracking, or not backtracking, what's it called? Substitution, back substitution, and I'm going to then work out what the values of x, y, and z are going to be. By the way, I just thought I should show you this as well. If you want to get something in fraction form really easily, just highlight over it and it actually comes up as the fraction like it is down the bottom. So I'll just jump over to the OneNote now and just show you. So just written this echelon form here. And again, this isn't the reduced rate echelon form because we don't have the identity matrix in here, but this is still useful to us. So this is, we'll call this x, we'll call this y, and we'll call that variable there z. So we could write this as, for this equation here, it's going to be 0 lots of x and 0 lots of y and 1 lot of z. So automatically we know that z is going to be 152/7. So if I just go back to the calculator really quickly, what was that? 21.7. Okay, we don't have to do this as a decimal form, but just to give you an idea. Okay, so now for the next one, we'll look at this row here. So we've got 0 lots of x, 1 lot of y plus 2/3 of z should be equal to 58 over 3. So I'm just going to substitute my value for z now into this equation here and rearrange to solve, and rearrange to solve for y. So I'm going to do this off screen and I'll come back. Okay, so I've just finished doing that calculation and the result that we got for y was, 34 over 7. All right, so we've got our value for z and we've got our value for y. And again, if you just wanted to do that as a decimal, you can. I'm just going to leave it as a fraction. I think I prefer the fractional forms. All right, now we're going to do the same thing for the last one. So the last one, nice and easy. We've got 1 lot of x plus 1 lot of y plus 1 lot of z is going to be equal to 35. We already know that y is equal to 34 over 7, and we already know that z is equal to 152 over 7. So now I'm just going to rearrange to solve for x, and I'll come back. So just rearranging that equation, I've got my value for x is going to be 59 over 7. So I didn't actually do this in the last video, and I kind of wish that I had because I don't think I got the correct solution. So what I want to do is I just want to go back and double check that those solutions are correct. And you can do that by substituting into that original expression. So let's just be pretty rough with this. If I have 6 students and 2 adults and 1 pensioners, I should get a value of $82. So what was the price for the students? What did we work out x to be? So x we worked out to be 59 over 7. So we should have 6 lots of 59 over 7 plus 2 lots of the adults. Now the adults we defined as y, and our value for y was 34 over 7. So 34 over 7, plus 1 lot of the pensioners' price, which we defined as z, and we defined that as 152 over 7. And now we just need to double check that that's equal to 82. So I'm just going to quickly chuck that in my calculator. So 6 lots of 59 over 7 plus 2 lots of 34 over 7 plus 1 lot of 152 over 7, and that is equal to 82. Fantastic. So 82 is equal to 82. Left-hand side is equal to the right-hand side. So our solution is therefore correct. So let me go ahead and write those solutions down the bottom here now. So x, y, and z is equal to 59 over 7, 34 over 7, and 152 over 7. All right, so that's how we find the solution using a calculator and by using that back substitution method. And I did double check again this time, so well done me. If you want some specific questions answered, please just send them through to me and I'll give them a go. So the other videos that I've had some requests for are to do with some of the complex number stuff. So that is probably what I will have up next for you guys. Alrighty, talk soon.